Hey guys, thanks for coming. We are really excited to have you here for Energy Saving Must-Haves. I'm Travis Brungardt. This is CJ Nielsen. We're going to get started if everybody's ready. I know we've got some people filtering in, but there's a lot going on at Build Show Live. We got to get started and stay on schedule, right? You want to kick it off, CJ, and maybe we'll do our intros?
Yeah, you want to? I'll go first.
Do it.
So this is fun for me because I'm co-hosting with Travis, but I think the perspective that we're going to kind of present in this presentation is Travis is a master electrician and a builder. And so Travis understands a lot of stuff outside of the electrical scope, but he also understands electrical. I'm tunnel vision, I'm all electrical. So I'm an electrical contractor in Northern California. We run a pretty small shop, 6 guys, 3 vans, but we primarily 100% work for custom home builders. So we live north of San Francisco. It's a pretty affluent area, a lot of big homes. And that's kind of like our focus is custom residential, ground up builds, working for general contractors. So I nerd out on all these little details. And also I like teaching.
Yeah.
So I think knowledge is power and we like sharing it. So that's, while we're on the Build Show.
Yeah, it's a beautiful thing to be part of this building science community and the Better Built efforts that are made, something we've all benefited from, got us here today. You're very generous, CJ, I appreciate that, but I'm actually really excited to be presenting with you because while I do hold a master electrician's license, in addition to other licenses, and I do build homes, I don't know if I've told you this before, I had to unfollow CJ on Instagram for a while. This is getting complex. Like his electrical work is so far superior to mine because that's his focus. You stay in that lane and you do it better than anyone that I've seen. So I am not on your level in the electrical department, so we have a nice symbiosis. I can talk about the builder side of things, and you really are the expert in this session. So we'll talk through a lot of different stuff in this today, but before we get started, just to reinforce what CJ said, I'm a builder in the middle of the map, right into Kansas City. So I'm working with my partner Joe Cook to construct a few custom homes a year. We are a similarly small shop. We have 4 or 5 guys that we run, doing a lot of self-performed plumbing, electrical, HVAC, in addition to our framing, trim carpentry, and all that. Everything that goes into the house, we do all that, but we don't quite nail it the way CJ nails it. So when we got the opportunity to work together on this, it was super exciting. When we move into the front end of a project, you and I are both looking at things very differently. You from the electrical side, especially as we talk about the energy saving must-haves, which of course that has a whole different connotation with regard to, government and energy saving from the standpoint of your pocketbook and all the different things that we have to consider. As a builder, I'm looking at it very holistically, and then I'm putting a lot of onus on my electrician to come through with all of the solutions in your arena. So working together on this presentation has been exciting, and I think we should go ahead and get this thing started because now that we know who we are, let's go.
And I don't want to read off the screen, but I kind of want our talking points. So like, what are we doing here?
Yeah.
We're talking about energy efficiency. We're talking about ground up. If you're building a house, factors that you want to take into consideration from a builder standpoint, from an electrician standpoint. And then whether you're a homeowner or a builder or an electrician, I think there's a lot of important things that are often overlooked or misunderstood. So I am from California, and we have a lot of energy codes. And so a lot of this stuff has just been forced on us from day one. And so I'm familiar with a lot of the things, and it's fun coming to these shows and talking to people in different areas that when I talk about things that I not take for granted, but literally we have to do. Motion sensors in bathrooms to save energy.
We don't do that.
LED requirements, we have Title 24, so we have rules we have to abide by to even pass inspection. So a lot of that stuff is not enforced everywhere, but I think it's important. So we're talking about indoor air quality, which...
Absolutely. So when we start talking about Electrify America in the modern sense, not the old let's pull the linemen all across the US and get them up poles, but the modern sense of electrify everything, it isn't really just about keeping the ailing grid alive or saving money in terms of heating and cooling efficiency. We're also addressing your indoor air quality with our electrical decisions because we're trying to get, and the code supports this. I'm not saying we are, even though we're electricians, and of course we benefit from not having as much natural gas and propane and those things feeding into the house because there's off-gassing. You're producing carbon monoxide when you burn those fossil fuels, and that introduced into a really tight home is a negative health outcome, and so the code is moving away from allowing that, and so that's the indoor air quality element of this discussion.
Yeah, and fossil fuels versus electric.
Right.
It's going that direction regardless, whether we like it or not. I mean, we read about it every day. Electric is being pushed in so many, and so it's something that, again, if it's not mandated, it's something that everyone should be considering.
Absolutely.
And then sustainability, obvious.
Yep.
I think it.
Continue. I was going to say that essentially the sustainability arguments about our environmental choices are pretty clear, and I always say when I'm faced with these sort of hot button topics in some discussions, was like, it's important to know where your electricity is coming from. In my market, a lot of it is still produced at a coal-fired power plant. So am I really saving the planet if I use more electricity and less natural gas? Not necessarily, but we're also engaging solar and wind energies to resolve that and make it a cleaner energy source, which is part of that sustainability argument.
And if we can be self-sustainable, I mean, I think anybody would want to, right?
Of course.
We can't control our energy costs. It's a bill we all have to pay every month. And so if we could control it, which now with technology, with solar and batteries, this is something like I dream of, like having an off-grid house. And I think it's realistic, right? 10 years ago, it was like, ooh, batteries, we can't, but it's going in that direction. It's getting better every day. So I think, again, it's just something that everyone should be thinking about. And then you kind of covered
I touched on the environmental already,
cool.
yeah. So in terms of, just to kind of bring that home, when we talk about sustainability and environmental responsibility together, we are talking about those things, but with respect to your footprint, the carbon footprint that everyone talks about, the environmental responsibility, that doesn't just resolve at, well, I shut the lights off when I went out of the house in the morning. We're also really talking about what it costs to increase the size of the grid and manage those loads and keep people, as we continue to build more and more, which obviously we're all involved in, we're having to build out that infrastructure, and the more we disrupt, the more that impact is felt. So if we can reduce that load and make things energy saving so that we're not having to increase those services, that allows us to be a little bit more environmentally responsible and maybe leave the place a little nicer for our grandkids.
Yeah. Should we talk about building houses?
That's a great idea. I love building houses.
So I mean, one of the first talking points, and me and Travis have talked about it a million, as an electrical contractor, we get blueprints constantly, right? A new build. Yeah. And one of the things that is like always a hindering point, at least in our stuff, is mechanical space. Yeah. So I have learned from many, many mistakes or being bullied by builders or designers that square footage is at a premium.
It is.
So when we're, there's not always the plan set shows where, I mean, there might be a little square on the plan that says the electrical vanity goes
mechanical
here. But it's a lot of discretion, and it's like a lot of negotiation at the beginning of the build, what makes the most sense for where the wiring is going to be. If a breaker trips, where are you going to go? Do you want to go outside, or do you want to go down in a mechanical room or the garage? So we're always fighting for space. And again, a lot of times it's driven by design. Yeah. And so I think one of the biggest things that I do up front now is I politic starting at the beginning of the build for mechanical space. And why? It's because stuff needs to go somewhere. Yeah. And it's too often that they're like, hey, can you put it behind a door? Or like, can you fit the battery up there? So there's so many reasons that, taking into consideration when you're looking at your plan set, that whether you're doing it now or you're going to do it later, is like, if we can mount batteries here, or if we have better access for maintenance, that's mechanical space.
Yeah, it's not just about what's going to get that house up and running. It's about the future proofing, because maybe your client isn't interested in battery storage yet, and maybe it's, hey, we're going to run a conduit for future ground-based solar, but someday there's a very good chance that the house of the future is going to include battery storage. And we want to make sure that there's a place for that to come into the house, to be serviced, and obviously meet code, so that we have that service access. So you've got to build it into what you're doing at this stage, because I've built a lot of room additions in my time. No one's ever asked me to come and build a mechanical room addition. I don't think that's happening.
It's always an oversight. And that's so right. I think, getting on it early, and again, it might not be something you're doing now, right? Batteries are very expensive.
They are.
And they're only going to get cheaper.
That's right.
So I think, I can't preach more mechanical space, spare conduits, and planned, right? So I said before, we work on custom homes.
Yep.
And some of them are over the top design, and it's always overlooked. But I think early on in any build is, even if you're not going to do it, sit down, and I'd rather make the mistakes on paper. The job
Much
gets
cheaper.
moving quick. When the house starts going up, there's so many moving pieces, there's so many trades fighting over what goes where. So I'd rather spend 3 days in the office and Zoom meetings talking about all these things.
Absolutely.
Again, even if it's not happening now, if you're putting a roof on, if you're not putting solar on now, putting on, the penetrations now before the roof goes on.
Especially with as much as we talk about building science, if I plan for a penetration now, I can detail it properly and I can be in control. As the builder, that's extremely important to me. If I'm going to potentially have someone come after I leave and mess with my stuff, I don't trust them. And so I want to plan for the solar now. I want to get the penetrations and the conduit in place so that I can seal them and make sure that my air and water control is going to remain intact. And that is a really simple thing to do at the plan stage, and then even easier when we're still on site. Once you're gone, you're trusting someone else with your stuff, but you're still the warranty holder.
So I think
plan
in
it well.
detail, when I say future-proofing, I don't want to gloss over it, but it would be, again, mechanical space, where you could put things, spare conduits, right? Infrastructure is relatively inexpensive, especially when you're doing a ground up, to get out of the building with multiple conduits, and just head them in it doesn't got to be crazy. Head them in a direction that you can land them in a ground box to where, like, later it's much easier to dig up and trench from there than it is to core drill through a foundation wall, compromise your building envelope. So cheap, it's too often that, again, we try, and nothing's better than when you come back a couple years later and you're like, oh, we have spare conduits.
Just pull this cap off and I'll feed this through and we'll be done.
Or if you're designing a wall, like, extra space is good.
Yes.
Put some shelves up and knowing that you can take them down and put some stuff there.
In the same way that you would plan your panel size, not for the absolute minimum spaces. You want to go ahead and plan the rest of your site conditions to allow for that expansion, because we're only going to add more devices. I don't know how many chargers and devices my kids have, but it's probably 5 or 6 more than I have. And in 5 years, I'll catch up to them and they'll have 10 more of whatever it is that we're using. It's just going to be more and more and more. So planning for that now is a great way to start. We want to actually not just think about the house itself, but the site as a whole. If we're going to talk about mechanical space and we're going to talk through maybe the structure of the house, first I want to talk about the site itself, because these things are going to interplay. You already talked about a buried conduit situation. If we're going to be trenching from a point of service to the house, okay, that's pretty obvious. That's where the service is. We want to put the house here.
Where's your power source? The utility poles on the back. I mean, you're there. It's not often that I'm on the site before it gets graded, and you're staking for the structure. So it's really like on a plan, drawing in where conduits are going from point A to point B, from the power source into your house, that you're trenching through something that maybe there's going to be a pool there. And again,
that's an important one.
It's not always, again, maybe a little added cost. And I think a lot of the times it's budget driven. And so point A to point B, the shortest route, cheaper. But I like when we meet with a builder like you and they're taking in those considerations. Of nothing's worse than digging up a brand new driveway or having to dig everything up and moving it over because you didn't think. And we've done it. We've been called to a lot of jobs where they're like, hey, we're putting a pool in, but the service route is directly through the backyard. And it was only a 2-year-old house, and nothing costs more money than having to do it retrofit or digging it up and compromising, again, the quality of it. So
100%.
Service route would be that.
That's key. We're also going to talk about, in terms of the site conditions, where this is really something that has to happen with the architect and potentially the surveyor as well as the builder.
Almost day one.
You really, especially if you're considering, hey, at some point there may be solar involved in this so that we can utilize that free energy. We probably are going to be talking about the orientation of the house, the directionality of the ridge. The solar installers are really great about coming out, and they're happy to do that. Find out where it's perfect azimuth, all that. All that stuff is key.
Sun exposure, trees.
The trees are the main thing that I always think of, is if we're actually going to put the house right here because you want to see that beautiful oak right out the front window, or at the back over the kitchen sink, I want to be looking at the beautiful trees. That's great. Those trees are a really good way to block the sun. And that can be a negative sometimes. So we're gonna wanna address that, and that might change that service routing, because if we're gonna stay in one trench so that we're not digging 6, let's figure this out on the front end. So that's what I mean by siting concerns.
Yeah.
We move on to structure now. This is something that you've touched on a little bit, but since I was just talking about solar, if you're considering rooftop solar, that's something that has to be considered at the time that you're designing the structure. Your structural engineer, especially if it's like a truss-built home, those trusses are gonna be designed to be as efficient as possible. The minimum amount that they can use and reach the loads that they have to supply, that's what they're going to put in to the design, because they know that everyone's always saying, well, how come this is so much money? No one thinks it's too good, it's too much. They're always trying to reduce it down. And if you're doing a stick-built roof, again, you just want to make sure that you have that structure concern. What about routing things through the house, CJ? Like, is it great if I put some LVL between my panel and the entire floor structure? Or how about some steel? Some things that you can't drill through. We got to talk about that on the plan set.
And obstructions, sometimes you can't get around certain things, right? You said steel. Sometimes there's just no-go zones. And there's ways around it, but I think having that conversation up front is exactly what we're talking about.
Absolutely.
When you said solar too, and we're talking about orientation of a roof, or if you're in an area that's heavily wooded, maybe there's no way around having rooftop solar. So we have some stuff, and we're going to show some couple of options that, again, I think are overlooked a little bit.
Yeah.
And so, energy efficiency, it's so many different things, and we'll try to get through all these things, but a few of them are LED lighting versus traditional lighting. I brought up earlier that a lot of the energy codes have driven us in California to do certain things for years, but traveling around, I realized that people still are using other sources of lighting or misinterpret what LED lighting is.
Sure.
The technology's mind-blowingly evolved, and there's zero, I can't think, and maybe later when we get into Q&A, someone can bring up why we would still use an incandescent bulb or those halogens that were very popular and still are very popular. And a lot of times it was driven because of like color rendering or light output, and they fixed all of that. And it's been, again, we have a lot of products that we've been using for years and years. I can't think of any reason to use traditional incandescent or halogen versus LED, so we'll cover that. We're going to talk about smart panels, and we got an awesome, the leader to me, Span, and we're going to cover that pretty extensively. I could talk for hours about it, but I'll try to keep it short. Another one is our solar integrations, and what we're going to talk about in conjunction with battery storage, which is getting really popular and moving really quick too.
Yeah, if you're producing power on site, why wouldn't you want to keep it there and then not have to be beholden to the brownouts that tend to come to your area in the summer, well, a little further south than you, but anyway.
And high power bills, and there's a lot of reasons, right? Electric vehicle charging, that's another hot one. I'm never gonna own an electric car. It's headed in that direction. There's a lot of cool reasons too, and again, when the cost comes down, I just think no matter what, we're gonna see them everywhere. We already are seeing them everywhere. So future-proofing or planning, even if it's not happening now, we'll cover that.
That's right.
Lighting control systems, something I'm a huge fan of, not only for aesthetics and functionality, but also there's a lot of stuff that can be built in
to
how you control your lighting that can eliminate a lot of that energy that you're just wasting because you're not controlling them properly. And then future-proofing, which is my favorite, and we've kind of already talked about.
A way to live.
Yes.
We want to live future-proofing.
So we'll talk about LED real quick. Again, can get nerdy about it. But LEDs, I mean, the number one is energy efficiency. So the best story I have with that is when we started, when I first started. So I was 17 when I started electrical. I'm 38 now, so it's been 21 years. I don't feel that old, but
you look great,
when I first started, we were, a traditional pot light or recessed light in the ceiling was always a 75 watt par 30. You just, I mean, and in an average house that we are doing in like the 3,500 square foot range, we can get 100 of those. So, I mean, it's simple math, 75 watts, and then you multiply it, it's a lot.
It is.
And so when the LED technology came out, it was super expensive, just like new technology is. But we would be taking out a 75 watt par 30 light bulb and putting in an LED retrofit trim, which would just screw in. You can find them at Home Depot everywhere now.
Sure.
But then it was like really cutting edge. And it was at that point, and it's even gotten more, it was 7-to-1. So every 7 fixtures you took out or put in, it equaled one of the old ones, because they're around, the equivalents are using 7 to 10 watts versus a 75 watt. And I don't know why we measure light bulbs in wattages. We don't anymore. Wattage is what the power you use. But since day
Come
one,
back
Edison,
for CJ's presentation on getting away from wattages for lights
so
next
lumen
year.
output. I mean, we're looking for a lot of things in lighting, right? The lumen output for how much wattage you're using. So
that's about energy efficiency and cost savings for sure.
Yeah.
But there's also some other elements to that. I spend a lot of time thinking about the temperature. Well, actually, I'm glossing over longevity.
Well, longevity is easy, right? The LEDs last a lot longer. The misinterpretation of like they last forever is not true.
Not
no
true.
electronics
Nothing
do,
does.
but they last significantly longer. And some of like the like bottom barrel metrics are like incandescent bulbs had like a 2,000 hour lifespan. So
sure.
I did work in maintenance for a short period of time, and one of our jobs was when street lights started going to LED. And there's still a lot of cities that are using traditional
mercury vapor,
high pressure sodium and metal halide. Our jobs were literally we would get an outage report and we would drive our bucket truck and we would change out light bulbs. Well, now LEDs kind of eliminated a lot of that just because now we have LEDs that are lasting 2,000 hours incandescent, 50,000 hours plus.
LED.
So again,
great.
Pretty easy math for someone that's good at math. Not
So,
me. But it's years and years and years.
Right.
So that would be
that's huge. I think from the builder side of that, I don't know if any of you have large operations. We have multiple model homes. Back in the day, when I was coming up, like 2005, working for a production home builder, one of my jobs as a project manager in the subdivision was to go around and make sure all the light bulbs were on and working well, so that as we showed all the models, when people walked in, it didn't look, because it looks kind of crummy when you got the 4-light sconce and this one bulb's out. It looks pretty trashy. You're not selling that house. So that was part of my deal. And the realtors were brutal about shutting stuff off.
Yeah.
Things would be left on all the time. We were accelerating those bulb replacements. And I think about it now, like I probably would have saved 85 to 150 hours a year.
Yeah.
That I wasted
and
changing
the cost
light
on
bulbs.
LEDs have come down, so there's zero reason.
So the longevity thing is one thing. Temperature is the thing that I
heat
think about a lot.
emission is something that I want Travis to touch on because, I mean, everyone's here because we're building nerds and it's a build science show.
Dorks.
So LEDs burn much cooler. There's still some heat involved. They're not no heat, but essentially with an incandescent bulb, you're heating a tungsten filament to extreme temperatures, and there are little heaters everywhere.
Yeah.
And so now when you're going LED, you're eliminating
a tremendous amount of heat load from your house. So if any of you are old enough to remember the Tasty Bake Oven, little girls were baking brownies in a little box with a frickin' light bulb.
Yeah.
So we're trying not to do that to
I was
ourselves.
a creepy crawler guy, though.
Oh, nice. Creepy crawler. Legit. So,
but same concept. You had a little oven and you cooked it.
So if you think about all the efforts that we're making to build these super high performance homes, we're doing all this fantastic air sealing and water management, and then we spend all this time on our thermal control layers to make sure that we retain the heat that we produce. You guys we're in Austin, Texas. It's freaking hot here in the summer.
ACs are running.
Do you want to pay to have your AC run that much more so you can run these super hot light bulbs? Every room that you're in my parents' house, I built my parents' house about 10 years ago, and that's probably more like 15 now. I'm getting old.
Yeah.
Sorry. We still put in incandescent bulbs in these cans. My folks go around the house in the dark. They would not turn the lights on. Like, it's so hot in here, we're not going to turn on the air conditioner. You know how dads are.
Yeah.
So it's like, it does really make a lot of difference, and it makes a ton of sense to not heat something up so that you can pay to cool it down.
Yeah.
That's kind of dumb, so I'm glad we're not doing that anymore.
Yeah, and this has nothing to do with LED or energy efficiency, but just again, I feel like there's a lot of misconception on LED. I get a lot of customers that are like, I don't like LED. And their interpretation of LED is this harsh 4,000 to 5,000 Kelvin, how we measure the color of the light.
Hospital light or shop light.
They've got it dialed in to where you get the warm, lighting science is the warmer, you go in a house, it's got that warm glow.
Yep.
Makes you feel comfortable. There's a lot of psychology behind lighting. And then that harsh white is like sanitary hospital, is what they use those color temperatures for. Well, now with LED, they've got it completely figured out where they can mimic that incandescent.
And dial it in.
And there's even stuff you can dial up and dial down to change the color temperature, to change the environment. So And then shapes and sizes, LEDs fit everywhere. We see LED everywhere now, tapes that you can stick under rails and stuff. So that's just LED fun
And
stuff.
even the old stuff that people are nostalgic for, the Edison base, or excuse me, with the
they've mimicked it.
Yeah, we can fake that out, and it looks cool, and you can get those effects too.
So I'll fly through these. These are
Yeah, do
just
it.
slides. They're hard to see. We don't got the giant screen, but essentially you could Google graphs and you can really see the difference between the different technologies and what LED does as far as efficiency goes, those ratios that I was talking about with power. And then lifespan, the green long bar is LED, how much longer it lasts than the little incandescent in hours.
And nothing lasts forever. I know that the manufacturer's claims will suggest that these are going to be the last light bulb you'll ever put in. It's an electronic device. There will occasionally be a batch that's not as good. And also those heat conditions. You know, if we put it in the garage and the attic's uninsulated and it's 160 degrees up there, you might be shortening the life of that fixture.
Exactly.
So keep that in mind. Have realistic expectations.
Cooling is still a thing with LED. You got to keep the drivers cool.
Yep.
They do still produce heat, but it's, again, significantly less. And then heat emission, we kind of covered that.
Yep.
Let's jump in because time goes fast. I want to talk about the smart panels.
Don't go too fast, CJ. This is one of my favorite things that you do.
It's something we're seeing more. It's still an early, hot, new thing.
Relatively, yeah.
Yeah, relatively new, and there's a lot of stuff coming out on the market. Just like any technology, when it moves quick, other people are adopting it. So there's different types of smart panels. And what is a smart panel? I'll spot specifically to span. My battery's running out, but if I
that's a bummer.
Yeah, it'll reset.
One of the coolest things about the span panel is when you open it up, you get this really sexy glow around it. Like, I've never seen a client be excited about their panel before. Like, I get excited about panels. So the flashing effect is just a function of the battery starting to let us know.
Reset. So it'll wake up.
Yeah.
But what span has done is made what has been around for 75 or 100 years with circuit breakers is a smart panel. And what is a smart panel and why do you need a smart panel? I think a lot of people instantly think like, oh, I can open up a phone and I can see the metrics, which is a selling point, right? You can open up your phone and you can see what individual breakers are using.
Yeah.
And
that's valuable because if we're not measuring something and we don't know what's going on with the house, then we're probably not going to change our behavior.
Yeah.
And maybe you don't need to change the behavior.
Behavior is exactly it. So it can influence your behavior. You could look at your bills. We all have different rates, but usually the utility companies are charging premium at premium peak hours. You're paying a lot more for your power. So analytics are fun for me. My wife won't open the app and care about those things. So that's not all it does.
For dorks only, right?
So what Span did is they have a microgrid behind where these breakers click in. The busing and everything else is traditional like it's been forever. But when I first found out about Span, I was like, I'm not into it. How am I gonna find breakers? So parts are a big thing. Span uses traditional breakers. So these breakers, there's multiple manufacturers that everyone has in their homes. They plug right on. So you're using essentially dumb breakers. There's nothing different. You could take your old breakers out and put them in, which is awesome. So they have a microgrid.
That's key because you've only got so many spots in your truck.
If I get a service call and I have a bad breaker or any bad part, I got to be able to find it.
Right.
So Span eliminated that. That made me feel really good.
It's great.
They have a microgrid behind each one of these breakers is a little switch. So essentially, you can manually input if you want to select to turn a breaker on and off. It's not tripping the breaker. It's literally just opening a switch behind it.
Yeah, throwing a switch.
But the big fancy part about Span is that it has a computer in it that is monitoring and recording everything that's happening within the panel. I think like a non-negotiable if you have batteries would be the biggest selling point of Span.
Sure.
So you have batteries and you have 2 Tesla Powerwalls or Franklin, any battery system has a certain amount of capacity, just like your cell phone. So when you have a power outage, that's why you have batteries. Well, if you have a power outage in a house and you have your HVAC running or anything in your electrical panel running, when you have a power outage, you only have so much capacity, and you're using that capacity to do things that you might not necessarily want to do. Right. So your HVAC's running, not an essential to me. I want my lights on, and I want my refrigerators to not defrost. That's why we have backup power batteries equivalent to generators. Generators too can.
They play nice together.
Yes, they play nice together, and it's also a feature, right? The more stuff you have drawing from your house when you have a power outage and your generator turns on, the more fuel you're using. So you're just burning fuel or burning battery capacity for no reason. Well, Span has priorities in your app that either you as a homeowner will set or your installer will set, and
Sure.
that's where you prioritize. So priorities ones, like again, would be for me, if I had a long outage, would just to keep my refrigerator and freezer from defrosting and keep some lights on and maybe some plugs for charging.
Sure.
But you can actually open your app and you can see if you have X amount of batteries, 1, 2, or 3, or infinite.
Yep.
You can see in your SPAN app how long you can sustain this outage using what you are using.
Right.
So for example, if you had an outage that was only a service outage for like a utility shutdown, we have those all the time. They email you and say, hey, we're going to turn off the power to do some maintenance. Well, if you have 8 Tesla Powerwalls, you just invested in all this infrastructure, you can go into that priority and you can rock and roll with everything. And it'll tell you, hey, you got a day.
Sure.
If you want to keep the hot tub going and your HVAC, you can do that. So SPAN automatically does that for you.
It's just empowering you as the user to make those choices or
without manual input, automated
right.
input. Manual input would be, oh, I'm having a power outage and I don't want my batteries to die. You run around and turn off the breakers. Again, some people will do that. Me and Travis probably would,
Dorks.
but my wife would not, and my clients won't. So SPAN opened up that huge window for maintaining your batteries during an outage.
Yeah, it's really key.
So that would be like very obvious. If you have batteries and you don't have a smart panel, you're just leaving a lot on the table, or you're not utilizing the batteries in the way they should be.
Even if you don't have the batteries, if you're planning for the future batteries, I still think there's something to understand about that load management, and also just to reemphasize the importance of educating your client. Like, the SPAN panel is amazing, and it honestly kind of sells itself a lot of the time. Just when the clients see it. But in terms of the things that it interfaces with and the problems that it solves without, as you said, our manual electrician coming to the job and fixing for you, it really does empower the consumer in a way that, I mean, all smart panels do, but in a very nice way. It makes it's a really simple thing to add to your build that your client isn't looking at, oh, this is a $600,000 change to add the swimming pool and the whole back landscaping. This is a very affordable change that's going to give you longevity. I don't know anyone that has changed their service panel because they wanted that functionality yet, but it's coming. What I'm seeing is people being able to utilize their limited services to do more with them.
That's where I save the best for last for me, as far as what I like about SPAN. We're in California, and if you're a builder or you're a homeowner or you have had any requests to upgrade your service site. So every house has a service where your meter is, and every service has a rating. And in our area, to upgrade that service to a higher rated service, more power, costs a lot of money. And our utility company in California is actually pulling out some neighborhoods. If you have a 100 amp service, and for example, you want to get an EV, or you get a hot tub, you add any load, right? You get a full HVAC system. All those appliances take more power if you have a full electric kitchen. So your electrician or your builder or your architect's going to be the bearer of bad news, usually saying, hey, we need to upgrade this service panel now. And you put it in an application in our area, you pay them a $2,500 engineering fee, and then they come back and they say, hey, from the pole to our house, to go from 200 amps to 400 amps is going to cost, we're doing a job right now where we're going from 400 to 600, which is a very large estate, but it's like a $76,000 bill from the power pole to my panel, not including all the work we have to do on our end. Well, SPAN's kind of eliminated that with technology. And so what we're able to do now with SPAN is, for example, if you had a house that was not eligible for an upgrade, and now you have 2 EVs, there's all the houses we're doing now, there's always his and hers or dual chargers. You've gone full electric kitchen, you have a hot tub, you have a pool, you have all these electric appliances, but now you do not have the capacity, and your utility company won't give you more, or it costs a boatload of money and months or years of planning. SPAN can regulate that. So just like in an outage, SPAN can prioritize the loads. For example, if every load has a priority, right? Everyone's priorities will be different, but that's where you can customize it to your liking. For example, if you had the oven on and it's drawing a full electric oven, double, and the range, it's Thanksgiving, you got a turkey going, we're drawing 40 or 50 amps there. We come home, the hot tub's going because you have guests over, there's another 30 or 40 amps there. It's hot out. air conditioning's on, there's another, and it climbs quick. So when we're designing a service, we have to take all those load calculations and determine what size our service is going to be.
That's right.
Well, SPAN can regulate that. For example, if you were at home and all those things were going on, and you come home and you plug in your EV and you crank it up, or you just park and plug in, unless you dial it down in the car, which you can do.
Right.
So you have to be conscious about that. You're going to trip your main breaker. I think everyone's tripped a breaker before.
Sure.
But when you throw your main breaker, that controls everything, and your entire house shuts down.
Not great.
That's what will happen. You exceed the rating of your service, and that's what would drive having a bigger service. So SPAN will prioritize that to where when you plug in the EVs, it will take into consideration, hey, you don't have that power right now, you cannot charge, or you cannot run the hot tub, or any scenario that you can think of as far as logic goes. And when those loads now go off, turkey's done, hot tub's not running,
now
cars are charging, or HVAC is running. So they've eliminated that. I mean, as far as an installer standpoint, I've had to be the bearer of bad news a lot, and explain to, and it's not a fun piece of a project. Like when people are spending $50,000 on an upgrade because they had to have the power pole changed out, it's not fun. It's not like a fancy front door or a pool. You don't really see it. People don't care about it
as much.
They make it. So SPAN is like the only one on the market that can do that right now.
Right.
So that's a huge, just
massive benefit.
Overlooked, I think, when people say, I don't need a smart panel. Not everyone needs a smart panel, but there will be reasons why you will need it.
Yeah, so if you're building new homes now, start thinking smart panels. They're going to be part of your future.
And time's ticking, so but I don't want to gloss over. SPAN also has an EV charger. You can go to any box store right now and buy an EV charger, or if you buy a Tesla, they come with them. SPAN's EV charger talks directly to SPAN. So, for example, we just did a garage. It was a bigger garage, and they have a lot of cars, and there's 4 chargers. And SPAN can automatically regulate through the SPAN drive. If you have them all plugged in, there's priority, right? So maybe you set a higher priority to whoever's driving more.
Sure, the daily
or
driver
maybe
gets
you
it.
only have so much power and you want them to all charge slow. SPAN talks directly to SPAN drive, which is really cool too.
Yeah, it's managing things for you so you don't have to.
Yep, exactly.
And that's going to allow you to have
convenience.
That's right, a better user experience.
And then a lot of pushback, because I've sat down with SPAN a lot. I'm not sponsored, I'm not paid by SPAN, but I did get to pummel. I like to be the devil's advocate, so I sat down on a webinar with SPAN engineers, and it was actually on the Build Show, so it's out there, it's on YouTube.
You can find it, CJ.
But we also had Facebook groups in asking questions, and there's a lot of like, what about this? What about that? All valid stuff, and they answered all of them. But one of the big ones would be serviceability. What happens with SPAN when, like any technology, it expires? Again, it's really traditional technology. They didn't reinvent the wheel. They're micro switches, there's a part number, you can get a new one. In my area, they're stocking them. So far as I need to service them, unbolt it, pull it out, put a new one in. The actual processor pulls right out. And so when you need an upgrade or they come out with something better, it's super serviceable. And then also, it's just like your phone. When new stuff comes out or the app changes, it's directly linked to the network, and you can get those updates, and you can change those settings. So as far as an installer go, I'm not like really worried about it. Everything has a service life, everything breaks, everything can be fixed. But SPAN's the market leader, and as far as I can tell, they've been around, and they've also worked out, they thought about all these things before they pumped out. Because another question was like, okay, what happens when the box changes? And they're not trying to release a new generation every year so that your technology expires. Using traditional breakers, and it looks cool.
Yeah.
And it's got those fancy LED lights in it. So there's a lot of cool stuff about SPAN. Again, there's other manufacturers out there.
Yeah.
There's going to be more. Schneider has one. Eaton has smart breakers. They all do different things.
Yeah.
Some talk to batteries. Some don't talk to batteries.
They all have their own little
Some are
apps.
just analytics. So you can also get panels that if you just wanted analytics, there's some pretty inexpensive stuff out there.
Right.
Again, to influence your behavior. If you're using, maybe you change your behavior because you're using the washer and dryer on peak hours, and you look at your app, which SPAN has, and it has a monetary a value,
Yes.
value attached based off your energy, and it'll say you're using. It costs you $18 every time you do a load of laundry or something. So span can influence the behavior or all their smart panels too.
Absolutely. It all comes down to your client behavior, and giving the information to the people that need it allows them to act on that information. To go back to a couple of the things we already touched on, just to sort of reinforce different reasons why you would make different choices. When we mentioned solar earlier, and we talked about how important the structure of the home is in terms of supporting that, if you think you might one day want that, running that conduit up, upsizing your trusses or your stick-built roof with your engineer's approval so that you can provide a rooftop array is a great way to not have to add space to your site.
And I think this is when I think of solar, or when most people think of solar, it's on the roof.
This is
which is an option. So again, if you're building a house and you don't want solar now, I think cheap insurance is consult with a solar company. They all kind of clip in the same way. Make your penetrations now, roof, and if you want to add later, you're not chopping up a good roof. You're not compromising waterproofing.
But my clients don't ever really want to do that. They're always thinking, well, in Kansas City, we get a hailstorm every 7 to 10 years. So we're redoing roofs. Well, if I need to redo the roof, the solar guy has to come back out and take everything off and put it all back on. Where do we storm during the project? So CJ, you mentioned a really popular thing that I think is brilliant.
So you could see the monitor. This is just like an out of the box thinking that I always, when I first saw it, I thought it was really cool. And I see it pop up more and more on jobs, is using solar as a shade structure, a carport. You're kind of getting a 2-for-1 in my head. You got a carport, you had to put a roof on it anyways. There's a lot of cool solar panels out there that are transparent, and they look cool to me.
I agree.
So, think outside the box. You could build awnings, overhangs, like I said, shade structures, carports. Cool.
And the next the next slide shows the one that I'm doing on my next project, which is ground-based. And I love a ground-based rack so that I have the opportunity as a client, ease of maintenance. They don't want to get on a ladder. They don't want to climb around on the roof and clean them, because you get maximum performance out of a panel that can receive the most of the sun's energy. So it does have to be cleaned and maintained. A ground-based array is fantastic if you have the space on site for it, and then that goes back to our conversation.
So lot will dictate that. We work on a lot of properties with a bunch of acreage, and you stick the solar array out wherever. And it functions really good because you can orient it anyway. Again, maintenance is a big one. So ground mount would be third options. Tesla roofs, we don't have a slide for Tesla roofs.
No, we don't.
That's a product that's out there where the shingles are your PV cells, which is pretty cool stuff. It's really new. We see them pop up, and I think it'll be more and more and more in the future when they start figuring out how to make them smaller.
I think that's what so much of this presentation is everything we're showing you is stuff that may seem like, oh, that's kind of new, and I don't know, that's going to catch on. This is where it's going. This is not really, this isn't Nostradamus up here, but I can tell you every house that I'm planning for, I may not be planning for this yet, and for those of you on that side, I'm blocking out the 4 batteries on the far right, but I'm definitely planning for the 2 on the left, because every little microgrid that we put together to bolster our aging infrastructure is what's going to keep that in service.
And so this is an extreme version, right? That's 5 Tesla Powerwalls on a project. But I just wanted a visual of like, they need space, they need access. Consider where you're going to put them, whether it's running a spare conduit and leaving it there for 10 years from now when you want to install a bunch of them, or we're driving to Costco and we're able to buy them on a pallet for a couple $100. It'll be there. So this is just a visual of, like, again, plan for space. They do take space and take it into consideration if you're building and you think maybe, or if.
You absolutely should. Plan on it, it's coming. Something I'm going to go over really quickly, when we talk about other mechanical equipment, we talked about how these tighter envelopes with better performance allow us to do really small HVAC, not blowing a bunch of energy of heat from incandescent bulbs as part of that. But we're also, with that smaller equipment, not just looking at heating and cooling of air and people conditioning, but actually water heating.
Full electric. I mean, I think most homes with gas have a gas water heater. But when we're building full electric homes, the water heating technology is pretty wild now. So this is a heat pump water heater. And then we also have another option, on-demand electric, which draws a significant amount of power. I was blown away the first time I ever saw the specs on one that could do a whole house. But Travis brings up a good point. Hot water demand is instant in that point. So there's a lot of different variables when it comes to choosing electric hot water.
As long as you allow for it in your planning, you can make any one of these strategies work, but definitely keep that in mind. Like, this is saving a bunch of energy, but it takes more physical space. A tankless on the wall unit takes little space, no venting, all those things make a difference.
So lighting controls is just something that, again, has been forced on us in California, dictated by Title 24. We're required to have motion sensors in bathrooms and common area, like mechanical spaces and laundry rooms, where when we enter the room, the lights know we're there through a little motion sensor, and when you exit the room, they turn off. So really simple, it's just turning your lights off for you.
Sure.
But I'm a big fan of lighting controls in general. That's a whole nother topic, but there's energy savings when you do have some sort of automation. There's a lot of out there.
Yeah.
Lutron's the leader, but regardless, you can set schedules, you can set occupancy, so when it sees you, it turns off. It could turn on too, but the energy saving would be turning off, and then dimming. Right,
dimming and
when
all
you
the...
dim down a light, it's going to use less power. So lighting controls integrate with energy efficiency,
100%.
I mean, pretty obviously, and lighting controls are cool. So I should do...
we'll do a follow-up presentation with CJ
one.
on lighting controls.
And then, obviously,
The
electric
induction
appliances.
ranges.
We all see them. We're doing a lot of full electric homes.
Oh, yeah.
And it's come a long way. I like to cook. I like a gas stove, but I just used an induction at a rental house on vacation.
Super nice, right?
And I loved it.
So something really quick, because we're actually out of time. I'll just close out this specific topic to remind you that your appliance selection makes a huge difference. And if your clients aren't already aware of, or if you're not aware of, like the 45L tax rebate, there's a lot of opportunities that you should research with EPA Energy Star, because you can actually pay for a lot of the improved things that your clients really want anyway with these rebates, and then provide a much better lifetime of the product and performance of the house.
Yeah, so electric cooking is kind of cool.
Absolutely.
So.
I think
And then we did HVAC.
I talked about it a little bit.
And there's a lot of HVAC, right, talk on the Build Show. It's gone full electric. It's really, really efficient. The technology is mind-blowing. Every house we're doing now is all electric
heat pumps.
HVAC.
Yeah, 100%.
And then laundry rooms, same technology. Matt with a beard is cool. And so, same
So
technology.
good.
They're drying clothes with heat pumps. And I think we're pretty wrapped. I think we'll
we're
stick
out of
around
time,
if
if you
people
guys have questions, yeah, absolutely.
or want to chat. But
We probably got meet and greets later too. That you guys can
and we're
find
around the
us.
show. We're on social media. Do you want to?
I'm at Catalyst Build.
And I'm at CNC_electric. So if you guys are on Instagram, follow us or DM us, talk to us. That's my favorite part.
It's the best.
We're always here to talk shop. So
Thank you for your
I
time.
appreciate you guys. And enjoy the rest of the show.
Yeah.